Hello friends, welcome to EC Academy. In today's lecture, let us understand the silicon gate process. First, we'll understand what do we do in this process. Here, we use something called as polysilicon. So, what is polysilicon? The polysilicon is nothing but polycrystalline silicon, and this polycrystalline silicon plays a very important role in semiconductor fabrication. And we use this polycrystalline silicon for two important things. First one, we use this polycrystalline silicon or polysilicon as an interconnect. If we say interconnect, which means it acts like a tiny wire connecting parts of integrated circuit, and also we'll use it as a gate electrode. So we use polysilicon as a gate electrode in our MOS transistor. The biggest advantage of using polysilicon gate is their self-aligned nature. If we say self-aligned, which means the parts automatically match up perfectly without having to align them manually. So here, the polysilicon, which is a polycrystalline silicon, is used as interconnect as well as gate electrode. The major advantage of this polycrystalline silicon is that it is having a self-aligned nature, which means the source and the drain region will be precisely defined, which improves the performance of the circuit. Now let us understand how we actually do the silicon gate process. There are 5 simple steps for silicon gate process. First, we'll take the silicon wafer and grow a thick layer of silicon dioxide over the wafer surface. We call this thick layer of silicon dioxide as field oxide. After growing this silicon dioxide, we'll remove some portion of silicon dioxide, which we call this as etching. And this etching is done only at the specific areas where our transistor need to be placed. Next, on the exposed silicon surface, which we have just created, we grow another layer of silicon dioxide, but this silicon dioxide layer will be very much thin and it is a strictly controlled layer. This thin layer is called as gate oxide, and this gate oxide will act as an insulating layer just below the polysilicon gate, which we will create in the next step. In the next step, an undoped polysilicon layer is deposited all over the wafer. After depositing the polysilicon all over the wafer, this polysilicon layer will be etched away in the correct shape to form our transistor gate and also to form the interconnection. Now remember this, student, this is very important step. In this step, the wafer is exposed to a dopant source. So when we expose the wafer to dopant source, it will do two things. First, the region where the dopant is exposed will form the source and drain junctions in the silicon substrate. The second thing will be, it dopes the polysilicon gate to reduce the electrical resistivity of the polysilicon. In this step, the polysilicon acts just like a mask. Since it is acting as a mask, it does not allow source and drain to extend below the gate region. This process is known as self-aligned, which I have told you at the beginning of the discussion. So finally, we'll cover the entire structure with one more layer of silicon dioxide. Then we remove or etch away this silicon dioxide layer, which will be the tiny holes for contact so that we can make the electrical connections. Lastly, a metallic layer like aluminum is deposited to complete the circuit. Finally, to summarize the process, in the first step, we take a wafer and we'll grow the thick silicon layer on the wafer, and region where the transistor has to be grown, that region will be removed. In the second step, a thin layer of silicon layer will be grown across the gate region. Above this thin layer, a polysilicon is deposited. In the fourth step, this wafer will be exposed to the dopant source so that the region which is not protected by polysilicon dioxide, below that source and drain junction is formed, and also the polysilicon across the gate region will lose its resistivity, and in the final step a silicon dioxide layer will be formed and small holes are created to make the contacts for source and drain, and the metallic layers are used to complete the circuit. This is about the silicon gate process. Hope you have understood the topic. Thank you.